Welcome to the DIY Honda Garage channel. The diagnostic trouble code P0116 indicates a problem with the Engine Coolant Temperature, ECT Sensor 1 circuit, specifically a range or performance issue. This sensor plays a critical role in providing vital information about the engine's temperature to the Engine Control Module, ECM. The ECM uses this data to make necessary adjustments for engine performance, fuel efficiency, and emissions. Typically located near the thermostat housing or engine block, the ECT sensor monitors the coolant temperature and sends this information to the ECM. Anomalies in the reading may lead to performance issues such as poor engine operation, reduced fuel efficiency, or even increased emissions. To effectively troubleshoot this error, it's essential to first capture any relevant freeze-frame data to understand under which conditions the error occurred, as this will guide further diagnostics. The Engine Coolant Temperature, ECT Sensor 1, associated with DTC P0116, is vital for monitoring the engine's coolant temperature. This sensor is typically situated near the thermostat housing, where it can effectively gauge the temperature of the engine coolant. The ECT sensor converts coolant temperature into an electrical signal that the ECM interprets to make real-time adjustments to fuel injection, ignition timing, and other parameters for optimal engine performance. When the readings from this sensor fall outside the expected range, it can lead to erratic engine behavior, including stalling or overheating. The effective operation of this sensor is essential for maintaining engine efficiency and preventing unnecessary wear. Therefore, any issues detected in this sensor's performance must be addressed promptly to avoid further complications. Several factors can contribute to the triggering of DTC P0116. One primary cause is a faulty engine coolant temperature, ECT Sensor 1, which may fail to provide accurate readings due to internal malfunction or sensor degradation over time. In addition, poor electrical connections can result in intermittent signals being sent to the Engine Control Module, ECM, which may confuse the system and lead to incorrect performance readings. Another common issue is loose terminals, which can disrupt the electrical flow between the ECT sensor and the ECM. Such disruptions can cause inconsistent data reporting and lead to performance issues. Identifying and addressing these potential causes will be critical in resolving the error and ensuring optimal vehicle operation. When DTC P0116 is triggered, several symptoms may manifest, which are primarily related to engine performance. One prominent symptom is noticeable changes in engine performance. The vehicle may exhibit stalling, especially during idle conditions, or erratic behaviors when accelerating. Another sign is the presence of an erratic idle, wherein the engine may fluctuate in RPM unexpectedly. Additionally, drivers often report a decline in fuel economy, which may arise because the ECM is working under incorrect assumptions about engine temperature and therefore adjusting fuel delivery inappropriately. If left unaddressed, these issues can lead to long-term engine damage, increased emissions, and overall reduced reliability of the vehicle. The first troubleshooting step for addressing DTC P0116 involves turning the ignition switch to the on position without starting the engine. This sets the system to a state where data can be observed. Using the Honda Diagnostics System, HDS, the technician will then check the readout for ECT Sensor 1 and observe whether it indicates a temperature of 176 degrees Fahrenheit, 80 degrees Celsius, or more. If the reading is indeed 176 degrees Fahrenheit or higher, the technician will note the exact temperature value for further analysis and proceed to Step 3 for additional diagnostics. However, if the reading is below this threshold, the technician must record this value and continue to Step 2 for a more thorough problem verification. This focused approach helps isolate the issue promptly. In the second step of troubleshooting DTC P0116, the technician will initiate the engine and maintain it at an engine speed of 3,000 RPM without any load, which can be done while the transmission is in either park P or neutral N position. This helps to raise the engine temperature effectively. During this period, the technician must wait until the radiator fan activates, which indicates the system is reaching operational temperatures. Following this, the HDS should be used to check the ECT sensor 1 reading once more. If the reading changes by 18 degrees Fahrenheit, 10 degrees Celsius or more, it suggests that the system may be functioning normally at this moment, indicating a potential intermittent failure. The technician should then examine any connections and terminals at ECT sensor 1 and the ECM for quality. Conversely, if no change is observed, this confirms a persistent issue requiring the replacement of ECT sensor 1, followed by repair verification steps. The third troubleshooting step requires turning the ignition switch to the lock 0 position to safely shut down the engine. After that, the technician needs to allow the engine to cool down for approximately 3 hours, ensuring accurate readings when the system is turned back on. After the cool down period, the technician will again turn the ignition switch to the on 2 position without starting the engine. The next step involves checking the ECT sensor 1 reading with the HDS. If the temperature shown changes by 18 degrees Fahrenheit, 10 degrees Celsius or more from what was previously recorded, this indicates potential intermittent issues, and the technician should check for any poor connections or loose terminals. However, if there is no significant change observed, this confirms a recurring problem that necessitates the replacement of ECT sensor 1 and subsequent repair verification to ensure the code has been cleared and the issue resolved. The repair verification step is crucial to ensure that any corrective measures taken have resolved the DTC P0116 issue. First, the technician must turn the ignition switch to the on 2 position, preparing the diagnostic system for checks. Following this, using the HDS, the ECM must be reset, which clears all stored fault codes and allows the system to relearn and adapt to any changes. After resetting the ECM, the technician will perform the ECM idle learn procedure, which is necessary for the ECM to accurately understand the new parameters for idle speed and other functions. It's essential to check for any pending or confirmed DTCs once again with the HDS. If the DTC P0116 appears again, the technician should revisit all connections and terminals related to ECT sensor 1 and the ECM to ensure proper installation and make adjustments if needed. If no DTCs remain, the troubleshooting is confirmed as complete. Final repair verification for DTC P0116 involves a thorough confirmation that all previously indicated diagnostic trouble codes have been cleared. The technician should review the vehicle's performance with the ECT system to ascertain that it is now functioning within expected parameters. It's important for the technician to confirm that the engine operates smoothly and efficiently without unusual temperature fluctuations or related issues that previously prompted the DTC. This phase ensures that any repairs or replacements made, such as that of the ECT sensor, have been effective in rectifying the underlying cause of the issue. Achieving optimal engine operation is the ultimate goal of the verification process. Ensuring both vehicle reliability and customer satisfaction are upheld. Implementing preventive maintenance for the ECT sensor can help avoid issues like those indicated by DTC P0116 in the future. Technicians should regularly check the ECT sensor for any signs of wear or damage during routine vehicle inspections. Apart from inspecting the sensor, It's equally important to audit the corresponding electrical connections for corrosion or looseness that might lead to erratic readings. Additionally, maintaining appropriate coolant levels is crucial, as low coolant can cause inaccurate temperature readings, further complicating engine performance. Preemptive actions in these areas can significantly extend the life of the ECT sensor and maintain an efficient cooling system, ultimately preventing future occurrences of similar trouble codes. In conclusion, DTC P0116 highlights issues with the Engine Coolant Temperature Sensor 1 circuit, prompting the need for detailed diagnostics. Following the outlined troubleshooting process can efficiently identify whether the ECT sensor is faulty or if poor connections are to blame for abnormal readings. Identifying intermittent issues early through these steps can save significant time and resources, ensuring the engine continues to operate smoothly. Moreover, preventive maintenance routines, including regular inspections of both the ECT sensor and the associated wiring, along with ensuring correct coolant levels, can greatly mitigate future risks. Keeping these elements in mind is essential for proper vehicle maintenance for the Honda Civic models between 2011 and 2015. Please like and subscribe to the channel. See you next time!